Hello, and welcome to the Middle Mathematical Contest in Modeling, the MidMCM, and the High School Mathematical Contest in Modeling, the HiMCM webinar. You'll notice that the MidMCM is new this year, and we're going to talk about that during this webinar. I'm Kathi Snook, and I'm the director of now both the HiMCM and the MidMCM. Please note that this webinar is being recorded. The recording policy is shown on this screen. Here's the agenda that we're going to follow during the webinar. And in a moment, I'll introduce our fellow panelists. Please note that we will take questions through the chat function. And so after the webinar presentation is complete, please type your questions into the chat and we'll get an opportunity to answer those questions. Our panelists today include Saul Garfunkel. He's the executive director of COMAP. And we also have John Tomicek. He's the contest coordinator here at COMAP.
Oh.
And again, I'm the director of the HiMCM and the MidMCM. We're so glad that you joined us today to learn about both of these contests. And we'll start with Saul, who's going to tell you a bit about COMAP. Saul.
Thanks, Kathi. So COMAP was founded a little bit over 40 years ago now as a nonprofit company dedicated to the improvement of mathematics education for students of all ages. Our mission is not just to improve mathematics education, but to do it through introducing students to real-world applications of mathematics and mathematical modeling, because we firmly believe that mathematics should be shown in the context of its use. Now, how have we done this? Well, over the years, we've produced materials, curriculum materials, and materials for professional development, teachers in print, in video, in multimedia formats. We have an undergraduate UMath journal, the newsletter consortium, which goes to all teachers. We've created even a Basel high school, four-year high school series called Mathematics Modeling Our World. And in addition, we have reports like the game report, which shows teachers what modeling is and what it isn't, and various and sundry other series that we've produced through funding from government agencies over the years. Now, in addition to these print and multimedia format materials, we've also developed international modeling contests. I want to start off by saying that the point of these contests has never been about simply rewarding bright students for good performance, although we do that. The idea was to change curricula, to change practice, by introducing students and teachers to real modeling problems taken over a significant period of time in a team environment. We would show students and teachers how mathematics actually, what it looks like in the real world, and hopefully change curriculum and change teachers' approach to the teaching of mathematics. We have several of these contests. The first one that we developed was the Mathematical Contest in Modeling in 1985, followed by the Interdisciplinary Contest in Modeling in 1999. These two contests take place each year for teams of undergraduate students. We also have the International Mathematical Modeling Challenge, which is a high school challenge based sort of on the Olympiad model with two teams per country. But the ones we're going to talk about today and spend more time on are the High School Mathematical Contest in Modeling, developed in 1999, and the Middle School Level Mathematical Contest in Modeling, which is new this year. To lead us off, John Tomicek, who is the COMAP contest coordinator, will start to describe these contests and how to get involved. John?
Thanks, Saul. Hello, my name is John Tomicek, and I'm the contest coordinator at COMAP. I manage and organize the COMAP contest and coordinate the interaction between advisors, team members, judges, and contest directors. I'm going to take this time to highlight steps involved in creating a HiMCM, MidMCM team. You can see the steps outlined in the slide provided. Step 1, form a team. Step 2, choose a team advisor. Step 3, review the rules. Step 4, register. And step 5, prepare. Step 1, form a team. A team can consist of up to 4 students. All students must be from the same school. Sorry, no exceptions can be made. Students for MidMCM must be less than 14.5 years old at the start of the contest. Step 2, choose a team advisor. Any faculty or staff member at your school can act as the team advisor. They do not have to be from the mathematics department. They will help to prepare the teams and help to familiarize the students with the contest rules and regulations. Step 3, review the rules. Teams and advisors are encouraged to review the rules and regulations. Be sure to check back as the rules and regulations change from year to year, and in some extreme cases may change during the contest. Step 4, register. Anyone, parent, student, teacher, or advisor can pay the contest registration fee. Once the payment has been processed, the advisor can now take over and complete the registration process. Step 5, prepare. It is highly recommended that the advisor help the teams prepare by giving them practice problems from mathmodels.org and allowing them to see some of the outstanding papers. At the end of this webinar, we'll have a list of resources that teams, parents, and advisors can use to help prepare teams. Contest teams should familiarize themselves with the contest dates and deadlines. Registration deadline. Teams must be registered by the deadline to compete. It is recommended that you do not wait until the last minute to register. Teams are encouraged to register well in advance if possible. Contest window opens. The contest problems go live, and the teams can now review the problems and choose one of the 3 problem choices. HiMCM teams choose HiMCM problem A or problem B. MidMCM teams choose MidMCM problem C, or can choose to compete in HiMCM by choosing problem A or problem B. Contest window closes. Teams should stop working. No more changes can be made after the contest deadline. Solution report deadline. Your solution email should be prepared and sent to solutions@comap.com. Anyone can send the email, team member or advisor. It is recommended that you only send 1 copy of each submission. Receipt of solution. 24 hours after the report deadline, we recommend that you log into the contest website using the advisor login link to verify that your team's electronic solution was received at COMAP. Contest results. The contest results will be posted on or before February 1st each year. Your advisor will receive an email with the results when the results are available on comap.com. At this point, I would like to invite Kathi Snook, the HiMCM MidMCM contest director, to speak with you.
Thank you, John. As John finished his presentation, he said the results will be available at the beginning of February each year. This slide shows the contest designations. The designations are based on the papers that are submitted each year. We can begin with above average papers. They'll be designated as honorable mentions. Then the better papers are meritorious, with the best papers making it to the final round and designated as finalists. The best of the best papers will be designated outstanding as they are judged in the final judging. Also, you'll note that the NCTM will give awards to one paper for each of the problems in our contest. I want to talk a little bit about how to achieve success in the contest and what we've seen over the years that constitutes an outstanding paper. First, it's important, and John talked about the resources that you have to prepare for the contest. There's many resources at the COMAP website indicated on the slide. I think there are two great resources that you should look at. One is the Procedures and Tips for a Great Experience, which is on the website. It has many, tips on how to do well for advisors and students. Additionally, the spring article in Consortium magazine is about the HiMCM, and it goes through what the judges are looking for, and it takes apart last year's problem. And you can see all of the different parts that are required to submit a great solution. So I'd encourage you to find that article from the Spring Consortium on the COMAP website. Let's look at some of the elements of those great papers. We're looking at an overall submission. So the paper gets looked at completely, starting with an executive summary and an introduction, assumptions with justifications, developing the model itself and applying it to the problem, and then taking a look at strengths and limitations, doing a bit of sensitivity analysis, and then coming up with a conclusion, answering the questions that were asked. Overall, you need to follow the contest rules. They're on the website, and you should take a look and know what the rules are. The number of pages, we've gone to a maximum of 25 pages, all inclusive for your entire submission document. Also, never put the names of the school or the students on the paper. Your presentation should be coherent and organized, well-written and articulate. Make sure you go back to the problem statement and see that you've answered all the questions that were asked. And communicate your solution clearly, as if you were telling someone a story about the problem. And finally, make sure that you cite all of the references that you used. You may have used websites or perhaps publications, so make sure you cite those correctly. And remember, one of the rules is that you cannot use any other sources outside the people that are on your team, the other students that make up your team. So only things that you can find on the web, inanimate. You can't use any other experts or your advisor in doing the problem. You'll start out with an executive summary and an introduction. Basically, the first page is just to tell the judge what you did. Restate the problem or the requirements in your own words and a short description of your method. And then you want to tell the judge about what you found out. So if there were 3 different requirements, you might summarize those on the first page and what your conclusion was or your recommendations. And then it's always a good idea to have a table of contents. It helps the reader to know what they're going to see in your paper. Then start the paper off with an introduction. Again, just a brief background and restatement. There may be some background information that you found out when you were doing research for the problem, and you want to include that in this part. Assumptions with justifications are so important. In the modeling process, we make assumptions in order to simplify the problem at hand. Most problems are fairly difficult, and so in order to tackle the problems with the mathematics that we know, we make some assumptions. And then each assumption should be justified, and it should also directly relate to your model. For example, in a recent problem, we were modeling the electricity used to charge personal electronic devices like your phone or your computer in a school building. And one team made the assumption that all students are in the building an average of 7 hours a day, Monday through Friday. And they justified that by indicating the hours that their school was in session and that maybe some students would be absent or miss part of the day. The model development is really the most important part of your paper. Tell the story of how you came up with your model. Define your variables. Remember to use appropriate units and ensure unit consistency. Are you talking about feet, or are you measuring weight in pounds? What are the units that you're using? Develop your model logically. Present the process that you used. Don't present all the models maybe that you developed along the way. Choose the one that you felt was best, the one that you used to solve the problem. Present it in its full form in your paper. And then clearly state your model's results according to the requirements that were in the problem. And always be creative. We see many, many solutions to the problems. There's not only one solution to our HiMCM and MidMCM problems. So be creative. Once you finish your model and you've answered the questions that were asked, look at your model and think about your results. What are the strengths of your model? What things does your model do very well? What are the limitations of your model? Perhaps there's some weaknesses that you just couldn't overcome. Perhaps if you had time, you would have done something else to make your model better. Tell us about that. Validate your model with a few examples. Try it out. Put some numbers in there. See how it works based on your intuition or against data that perhaps you find on the web. Finally, sensitivity analysis. Many times you're making some assumptions or choosing some values to put into your model. Change those values and see what happens. That's what sensitivity is. How sensitive are your results to some of your assumptions or the data that you used? Finally, you should at least wrap it up with a short paragraph that concludes your paper and just tells of your final findings or your final recommendations. Additionally, as I mentioned before, make sure you cite all the sources that you used. You may want to use data, figures, graphs, images, and they may come from other places. And so you should cite where you got them from. Let me give you an example of a recent HiMCM problem. We asked students to take a look at roller coasters around the globe. There's many of them, and there's also many rankings or rating systems that take maybe a rider's experience into account. But we wanted you to look at simply the quantitative and objective data that you could find on roller coasters and see if you could develop a roller coaster ranking system. And then students were to take their ranking system, apply it to some roller coaster data, and figure out the top 10 coasters in the world. I think students really enjoyed that experience. It was good for data analysis, good for looking at patterns. I think it was fun. Here's some other example problems that we've used for the HiMCM in the past. You've probably seen on television different light displays that are now done using drones. And so we had our teams look at developing some light displays. They came up with a Ferris wheel and a dragon. We had students look at potential next generation home climate control. You know, can you make sure that your home is warm when you come from outside, from school maybe? Or that it cools down and doesn't waste energy in the summer or in the winter when you're not home. We looked at bottle battles, the impact of not allowing single serving bottles be sold, positive impacts and negative impacts. We looked at funding biodiversity conservation. We have limited funds. How do we spend them for endangered or threatened species? Since our MidMCM is new, we haven't had any problems for that yet. We expect to have an example problem posted online by October 1st. So you can take a look at that and see the level of the problem and the structure of the problem for your students that want to compete in the middle mathematical contest for modeling. So what do you have to look forward to now and in the future? Well, we're hoping that our MidMCM will really attract students that are 14 and a half years of age or younger to form a team and to compete in this new contest. The only requirement is middle school or level mathematics. And I've listed some examples on the screen. Again, our HiMCM has been around for a little while, and the only requirement is high school level mathematics. And some examples of algebra, geometry, et cetera, are on the screen. We're really looking for students to use the mathematics that they've learned in school and that they understand. Going further, we have 2 undergraduate level contests, the mathematical contest in modeling and the interdisciplinary contest in modeling. High school students can compete in these modeling contests, and you can go to the COMAP website to get more information. Skills that are looked for in the undergraduate contests, they get a little more into the engineering, science, technology, environmental, policy, other areas like that. The participants come from across many departments and many disciplines, and the advisors also are very varied. I want to point you to some places where you can get the most update information on the contest. First, we have the HiMCM, MidMCM webinar webpage. This webinar will be posted on that page. And there are some other webinars there that you can take a look at. You should follow us on Twitter, if you have Twitter, at COMAP Math, or if you're on Weibo, you can follow at COMAP China Official. Those 2 social media sites will put out the latest information as we have begun registration, as we're taking a look at the contest opening on November 3rd this year. You can always reach us by email at info@comap.com. So visit the webpage often, take a look at mathmodels.org. You can download materials that were discussed during this webinar and get answers to your questions. At this point, I would welcome you to enter your questions into the chat, and we'll be happy to answer any questions that you have. And I do have a couple things that didn't come up in the webinar that I think John, as we have some time, I think can address, or Saul can address. So first I want to say that I know that there's a lot of schools that may still be learning remotely or doing some partial work virtually. And so we will continue to allow students to work virtually. We encourage students to work together in their teams. We think that's great when students work together in person, but if that is an issue, we do allow students to work virtually. Remember, your team may only communicate with people that are within their own teams. They can't discuss the problem with any other people or any other experts, and they can't use interactive websites or web discussions. The other thing I wanted to point out is that a few years ago, the HiMCM, and so now the HiMCM and MidMCM, went to a 14-day window. And so students may work at their own pace and when they can during the 14-day window. The problems aren't any more difficult. It just allows our busy high school students and now our middle school and middle level students to schedule their work time around their other academic requirements. John, can you tell us how many teams participate in the HiMCM?
Last year we had roughly 1,000 teams from all over the world compete. There's no limit to the amount of teams an individual school can have in the contest, and there's no limit to how many teams an advisor can sponsor in the contest. So we had roughly 1,000 teams last year.
And those teams were international?
Correct, international, all over the world.
Okay, great. How about if, I know we say that a team can consist of up to 4 students. Do you have to have 4 students?
Nope, a team can consist of one student or any combination in between four. If you do have more than one student, obviously we made it clear that all the students need to be from the same school. So you could have a team of 1, 2, 3, or 4. One thing that is new for this year, the MidMCM, the students on the team all have to be 14 and a half and younger to be considered a MidMCM team at the start of the contest. If they are older than 14 and a half, they can still compete. They just compete in the HiMCM.
Okay, great. I know that at the end of the contest, everyone is trying to get their papers into you and they email them into you. And can you just go over again that they upload and what they should do to check to make sure you got their paper?
After the contest has ended, usually 24 hours after, an advisor will be able to log into their advisor account, and right on the information page where they log in, the advisor homepage, there'll be a download link to download a file that will include a list of all the submissions and whether it's been received or not. So we encourage the advisors to log in at that time and check to be sure that their papers were received correctly. If you, for some reason, you find that your paper is listed as not in at that point, send us an email immediately with the team number, and we'll do our best to work with you to try to find the location of that paper. And if there is an issue, we'll fix that immediately.
Great, thank you. We do have a question about if a student can be the advisor of their own team. And I will tell you that at the MidMCM and at the HiMCM level contest, no, a student cannot be the advisor of their own team. That is available for our undergraduate contests, but not at our school level contests.
Just touching on one thing to make clear is that, like we mentioned in the presentation, you do need an advisor, but the advisor does not have to be from the math department. It does not have to be a math teacher. It could be any faculty at the school where you're registered. So it does not have to be from the math department.
Thank you. I know, John, you get this question every year, and so I'm going to go ahead and have you answer it, and it will be on the webinar. When advisors register their team, they put in the team members' names, and they have to, list someone first and second and third and fourth. And when you do the designations come out with the certificates, you list the names just as the advisors put them in. So can you give some hints or advice to advisors when they're signing up their teams?
Sure. All of COMAP contests are a true team competition. And we stress the word team, meaning that the order of the names on the certificate have no bearing in importance or how much they contributed to the solution. Everybody is equal in the minds of the contest, in the directors, and in COMAP. It's a true team competition. So the order of the names is just inputted by the advisor, and that's the way that we print out the certificates and the way that the results are announced on the website. So the order has no bearing on importance or anything like that. There's no captain, so to say, on the team. Everybody is equal.
Great, thank you. And would love for Saul to address this as it comes up. We've been having the HiMCM for some number of years, and you've seen a lot of student work and student papers. And we always say, just do the math that you understand and that you can actually use for the problem. Have you seen changes in the years over what students do in the contest?
Well, certainly, as curricular changes, as the ability to use technology changes, as more schools spend more time in data analysis, you find that students are able to handle larger data sets and bring to bear more mathematics. But one thing that needs to be, which you've said, but we need to emphasize, is when we design questions, it's very important that students, in solving them, use the mathematics they know, not simply try to use a higher level of mathematics because they think that if they use mathematics that's typically taught at a higher level, that somehow the judges will think better of them. It's actually not true. It's important that students use the mathematics that they can actually handle and understand well. And we try very hard to design questions that don't reward students or teams who happen to have taken more courses or know more mathematics. We've had many examples where students have solved a problem by using very elementary means, but the model has been more creative and the solution has been closer to the real solution that we were hoping for. And of course, as Kathy's already indicated, there's no right answer. There are many models that will work and will get at the underlying questions in the problem. And often we don't know those. We don't walk into a grading session saying, well, if they're going to do the first problem, they better do it this way, where this is the technique. Isn't true. We get surprised all the time, and we look for those surprises. We hope for them. So creativity is definitely valued, and it isn't simply a question of the level of mathematics.
Excellent. Thank you. And again, that's just so important. Yeah, we want students to understand and be able to explain and use the mathematics they know. I know we get a question all the time, and Saul mentioned the use of technology as the solutions have changed. We get the question of, do students have to use technology? Is there a certain software program they have to use? Is there a certain, technique that they need? No. Again, students can use technology if they understand and use the appropriate technology. They don't have to. There's no particular software that we think students need. Everything that students need to solve the problem in terms of information will be in the problem statement. So they don't have to go elsewhere for any additional information. Besides, perhaps they probably want to do some background research, but we provide all the information that they need.
Touching on that real quick, I just want to mention that COMAP will never ask you to purchase any other material online. As Kathi mentioned, the problems are all self-contained. If their problem has data that goes with it, we supply that data. We'll never ask you to go to another website and purchase anything. If you do happen to go to a website that is selling data or solutions or any type of background information for the problems, it is not endorsed by us, and we will never ask you to do that.
Great. Thanks, John, for adding that. The other question that we get a lot is, can I really do the contest? Can my students do the contest? They're not in the advanced classes. So again, I just want to emphasize the problems that we have for HiMCM and for our new MidMCM are accessible on a variety of levels. So I think all students can look at our problems and do a solution to the problems. And if they don't finish every requirement, that's okay. They should still turn in their paper. They should do as much as they can. And what we're looking for is for students to attempt to do the requirements, to do the best they can at their level of mathematics. And you'll become a successful participant, and you might be surprised how much you can do to get an honorable mention, a meritorious, or even above that. So we really encourage all students to participate in the contest. It's a very positive experience. It's a great team building experience. It's a great opportunity to see how mathematics is used. So we just want to encourage that. I'm going to go back to our panelists and ask if you can think of anything else that we should share that we haven't already addressed. John?
I can just go over some tips, some common mistakes that teams make. Time management is a big thing. It seems 14 day window to do the contest, it still seems that when you come down to that last day that you're getting ready to submit your paper, that that time runs out really quick. So you want to manage your time accordingly. Make sure you give yourself enough time to finish up your summary sheet. Make sure that you check your control number and you get your control number correct. A lot of time teams transpose numbers and type in the wrong number in a paper, or they send in their solution to the wrong email address. You want to be clear that you have that checklist, that you're sending your solution to solutions, to send that to solutions@comap.com. Make sure that you have it named correctly. And then you just want to make sure that you give yourself enough time to finish up that paper and get it in on time. And like Kathi mentioned, you really want to download and look at that tips article, which has a lot of tips and which covers a lot of the common mistakes. You also want to be sure that you submit your file correctly, meaning that it's an attached PDF file. We don't accept any other type of file, no Microsoft Word, or we don't need any spreadsheets or Excel files. There's no data. You don't need to submit your data. All we're looking for is your PDF report, 25 pages or less, attached to an email. Don't use a cloud storage like Google Docs or Microsoft or anything like that, or Dropbox. It has to be an email with an attachment. I think those are very important, and those are some common mistakes that teams make.
Great. Thanks, John. And Saul, any other comments about the contests?
Well, I just want to reemphasize the last thing that you said. It isn't about winning. Yes, it's nice to win. It's nice to get a higher grade or higher designation, but the experience itself is changing people. I mean, it really is a different. Math students, unfortunately, frequently are sitting back and being lectured to and are not participating. The idea of a team experience where people actually have to work together is unique, I think, in the mathematics community, and modeling calls for that, because the different kinds of problems which come from the real world, different students, whether they're the strongest math student or not, may have experiences that the other students don't have, because it's real life and people have real, and so that sharing and working together on a real problem, which is the way they will work if they go into industry or do mathematics, so to speak, for a living. It really changes kids. It's an educational experience like none that they've ever had. It's intense in some ways, but I think it's one that we are really proud to have offered to students. And I think that it's something that they will value whether or not they turn out to have a high designation or not. So I think that's very important. I also want to say, by the way, that as John mentioned, with respect to the fact that it's a team competition and we treat everybody equal, we don't rank the winners 1, 2, 3. There's no ordinal ranking. If there are 4 outstanding teams, there are 4 outstanding teams. If there are 15 meritorious, there are 15. It's not like there's the top outstanding or the same. Everything is treated as though they're all equal within that designation. And that's part of our philosophy. We're not trying to find the best team. We're trying to value good work. And the work in itself, in and of itself, is of enormous value to the students, and I hope to the teachers as well.
Excellent. I could not have said it any better. Thank you. I think that's probably all the questions that we have today. And so I would like to thank you for coming to the webinar, whether you're here in person or whether you're watching the recording of this webinar. Hopefully it was informative for you as a teacher, as a student, as a parent. And we hope that you'll take a look at our website and get some more information both about the HiMCM and the MidMCM, and form a team and register for the contest. Here again is the information of the panelists today. You can always write an email to info@comap.com if you have specific questions. And you can take a look at our website. And again, there's our social media. So thank you very much for coming to the webinar. Happy modeling.
Bye.
Thank you.